Hey, this is a video for 4.3, Ionic Compounds. So go ahead and set up a new entry in your Cornell notes. Remember to start a new page for this video. Also check out the essential vocabulary. Today we'll be discussing transition metals. Alright, this is a disclaimer. This is probably one of the most confusing things that you'll ever do. This is something that students have really messed up when it comes to the reagents, and this is one of these skills that you just have to get. So we're going to be doing a lot of practice, and just bear with me. So to begin, a transition metal, these are transition metals. I told you in the beginning when we were talking about the periodic table, these guys are a little bit weird and dicey, but they're metals that have their valence electrons in 2 orbitals instead of 1. So they have a lot of different characteristics. They still do have metallic properties, however they behave differently in reactions, and we have different forms of these metals. So for example, iron has 2 oxidation states. Don't worry about these oxidation states, we'll talk more about these in detail, but we have iron 2 and iron 3. Iron 2, when you see it written out, means it has a +2 charge. Iron 3 has a +3 charge. So there's 2 different types of irons, and they're going to behave slightly differently. So when you're writing an ionic compound, this is when you're given the name, you're going to have this type of a setup, and this is the setup that I use, and I think it works really well. It's pretty foolproof. Here's some easy ones. So basically you're going to put the ion with the charge. Positive will go here, negative will go here. And when you're dealing with these negative ones, if you have anything from group 17, you'll see they have multiple oxidation states. Again, don't pay attention to the oxidation states. In an ionic compound, this one wants to form, it wants 1 valence electron. So this is going to have a charge of -1 when it becomes an ion. In group 16, it wants 2 valence electrons, 1 here, 1 here. It's going to have a charge of -2. Group 15 is going to have a charge of -3, 1, 2, 3. Okay? So here's an example of an easy one. We have lithium chloride. So what you're going to do is put the ion with the charge Li plus Cl minus. Now, if you notice, +1, -1, the overall charge will not change. So +1, -1. How many do you need of each one to make that charge? You only need 1. So when you write this formula, you don't put a subscript. You just write LiCl, lithium chloride. Now, when you're naming these, it's a little bit different. We will be practicing these in person, but instead of saying chlorine, you just change the ending, chloride. Oxide, sulfide, bromide, fluoride, nitride, carbide, iodide. All of these, you just literally IDE instead of INE or whatever the ending is. Magnesium oxide. So the first step, we have magnesium is right here, oxygen is right here. That means +2, that means -2. And this is the way it's written. If you write +2 and you write -2, it's okay. This is just the way that is official. You won't get points taken off if you write plus if you switch the order. Now, this has an overall +2, this has an overall -2. So the overall charge will be +2, -2. How many do you need of each so that they are balanced? You need 1. So the formula for magnesium oxide will be MgO. I know this seems, these are easy, okay? Now we're getting into something that's medium. So we're going to use magnesium again. Again, that is a +2. And chlorine is group 17. It's going to be -1. All right, so now we have a +2 and we have a -1. So these are actually, the overall charge has to be 2. It has to be +2 and it has to be -2 in order to balance out and be neutral. So the quantity, now you need to see, we have a 2+, how to get to +2? How many of these do I need to get to +2? I only need 1. How many chlorines do I need? I need 2. So when I'm writing the formula for magnesium chloride, I write MgCl2. Again, this is giving a +2, this is giving 2 -1s, so that is overall going to be a neutral compound. Now, aluminum oxide. Aluminum oxide, aluminum, it has a +3, oxygen has a -2. Al3+, O2-. Okay, now it gets a little bit dicey because 3 doesn't go into 2, 2 doesn't go into 3. But what number do they both have in common? they both go into 6. So the overall charge of the aluminum has to be plus 6. The overall charge of the oxygen has to be minus 6. How many aluminums to get to this plus 6? How many oxygens to get to that minus 6? I need 2 here, and I need 3 here. So I need aluminum, 2 of them, oxygen, 3 of them. How do I write it? Al2O3, aluminum oxide. Iron 2 phosphide. Now this 2 means that it is a plus 2 charge. Phosphorus is in this group. It is a minus 3. 2 plus, 3 minus. This is very similar to the one we just did. They both go into the number 6. 2 into 6, 3 into 6. 2 goes into 6 3 times. 3 goes into 6 2 times. I'm going to have 3 irons and 2 phosphorus. Fe3P2. Now here are some difficult ones. I have manganese 4 phosphate. Now phosphate doesn't have an IDE ending. That's from table E. So phosphate, PO4, 3 minus. Well, this PO4 kind of trips people up, but really you can just put an X there. So even if it's Mn4 plus, X, 3 minus, this 3 minus is all we care about. This is a plus 4 charge. This is a minus 3 charge. What number do these two both have in common? They both go into 12. So I'm going to have a plus 12 charge for the manganese and a minus 12 charge for the phosphate. So again, anytime you see something that doesn't end in IDE, automatically look to table E. Because there's phosphate, there's sulfate, there's nitrate, there's nitrite, there's chlorate, chloride, like all chlorite. There's all of these different endings. If it doesn't have an IDE ending, table E. Manganese goes into 12 3 times. Phosphate, or -3 goes into -12 4 times. Now, when I write this, I need to show that I have 3 manganese and 4 phosphates. So this is one of those situations where I'm going to need a parentheses. Mn3 PO4 with the 4 behind the parentheses. So that was a lot. We're going to be doing some practicing. I would like you to respond to this check for understanding. I hope that this video is informative. I thank you for your patience, and I will see you soon.